Now, with regard to any machine, we also need to talk about something called efficiency of a machine. Now, what is this efficiency? Efficiency is the work done by the machine divided by the work done on the machine. Now, to make any machine work, we are applying a force or effort on the machine, and the machine also moves. So we are doing work on the machine. But then what happens is, because of the work that we are doing on the machine, or because of the input work that we are doing on the machine also in return does some work by itself. Like in case of the hammer, it drives the nail inside a wooden block. Therefore, the work done by the machine divided by the work done on the machine is called the efficiency of a machine. Every machine, be it a simple machine or a complex machine, any machine will have its efficiency. And like I've already said, efficiency is the work done by the machine divided by work done on the machine, or output work divided by input work, where output work, of course, is the work done by the machine. And input work is the work that we are doing on the machine. Now, for an ideal machine meaning a machine which only exists in our imagination, in which there is no loss of energy in any way. So to say, any real machine that we see, any simple machine or any complex machine that we see is not an ideal machine. So only for an ideal machine, remember, the value of its efficiency will be equal to 1 or 100%. Now what does this mean? This means that for an ideal machine, the output work or the work done by the machine is equal to input work or equal to the work done on the machine. For all actual or real machines that exist in reality, that we have seen or worked with, for all real machines, efficiency will always be lesser than 1. This means efficiency is always lesser than 100%. Now why is that so? That is because in all real machines, friction comes into play. Whenever we are working with any kind of a real machine, be it a simple machine or a complex machine, there is force of friction that comes into play between the moving parts of a machine. So to say, the energy that we spend on the machine is wasted also to overcome the force of friction. It is because of this force of friction, which we also need to overcome, that the input work will always be greater than the output work for real machines. Because of which, for real machines, the efficiency will always be lesser than 1 or always lesser than 100%. Let us now look at the 4 basic functions of simple machines. Simple machines help us to reduce the effort to lift up any load. Say for example, we have a nail which is fixed on a wooden board. Now it will be very difficult for us to pull this nail out of the wooden board with our hands without using any tool or without using any machine. It will be very difficult for us to pull this nail. But if we use a claw hammer like this, so just by applying a very small effort, it will be very easy for us to pull this nail out. So therefore, simple machines help us to reduce the effort. Like in this case, just by using a small effort, we can easily pull out the nail. Another function of a simple machine is that it changes the direction of effort in a convenient direction. Say for example, we are trying to pull up a heavy load using a rope. So what we do is we pull this rope up, and thereby this load also gets pulled up. This is also true when we are trying to pull up a bucket of water from a well. So in order to pull this load up, we are applying a force in the upward direction because we are pulling the rope in the upward direction itself. But if we have a simple machine like a pulley, what we can do is, because of the pulley, we will pull the rope down. That is, the direction of the effort is in the downward direction, but still the load or the bucket of water gets pulled in the upward direction. So what has happened because of the simple machine, which is the pulley in this case? What has happened is the direction of the effort has been changed to a convenient direction, because it is much more convenient for us to apply the effort or to pull the rope in the downward direction than to pull the rope in the upward direction this way. So remember, simple machines also help us to change the direction of the effort in a convenient direction. The third function is that it changes the point of application of effort to a convenient point. Now, in order to understand the third point, you have to imagine riding a bicycle. Now, here is a crude picture of a bicycle that I've made. So, in order to make the bicycle move in the forward direction, we need to make the rear wheel rotate. Now, once the rear wheel starts rotating, the wheel to the front also starts rotating all by itself. But to make the rear wheel rotate, we do not exactly apply the force on the rear wheel itself. What we rather do is, we apply a force on the pedal. Now, since the pedal is connected to the rear wheel through this chain, so therefore, in order to make the rear wheel rotate, we apply the force or the effort here, when we actually should have applied a force or effort here to make the rear wheel rotate. So what have we done? We've changed the point of application of effort or force to a convenient point. Finally, the fourth function of a simple machine is that it increases the distance moved by the load. To understand this point, let us first give a look at a very short animation. So you could see in the animation that we have a pair of scissors, and here is where we apply the effort, and here in between the blades of the scissor is where the load is kept. So you could see in the animation also, when the effort moves a very short distance here, the blades of the scissor cuts a very long length of the cloth. So what is happening? When the effort moves a very short distance, the load moves a very long distance, because the blades of the scissor cuts a very long length or very long piece of the cloth. So a simple machine, which in this case is the pair of scissors, also helps to increase the distance moved by the load when the effort itself moves a very short distance. Now finally, do remember, for any kind of a simple machine, whatever kind of a simple machine it be, for any kind of a machine we can calculate something called its mechanical advantage, denoted by m dot a, which is the ratio of the load to the effort. So mechanical advantage, remember, is equal to load divided by effort.